Jai Hind to all of you. I am Dr. Gaurav Saxena, Associate Professor in EC Department. Today I have discussed the Unit 3 of Fundamental of Electronics Engineering BEC 101, having a title of Operational Amplifier and its application. So, what is the meaning of the operational amplifier? So, operational amplifier is such amplifier which amplify the very low signal in the range of millivolt. So, that means this is a very high gain differential amplifier having a high input impedance and very low output impedance. So, that means for ideally, so we can say, so the ideal characteristics of the operational amplifier is giving that means the input impedance of an ideal operational amplifier is to be the infinity ohm for improving the loading effects. And the second one is the output impedance of that particular op-amp should be in the range of 0 ohm, but practical application we have to be in the range of 75 to 100 ohm, and this one is 2 to 3 mega ohm. And the third one is what is the slew rate. So, the slew rate is the what is the output maximum output change of that particular amplifier with respect to the time, that means the dV naught upon dt. So, maximum output change with respect to the time is governed in the topic of the slew rate, and the slew rate for ideal op-amp should be 100 or we can say that which one is equal to infinite volt per microsecond. Fourth one is the major ideal op-amp characteristics is CMRR. CMRR, what is the meaning of CMRR? CMRR is the rejection capability of an op-amp. Generally, we have to be use the CMRR. The CMRR full form is common mode rejection ratio. So, what is the meaning of CMRR? This is the ratio of the difference mode gain to the common mode gain. For ideal op-amp, it should be the infinite dB, but in the practical application, the value of this is 60 to 90 dB. And the fifth one is bandwidth. So, bandwidth utilized by that particular op-amp, that means the ideal op-amp we have to be taken here. So, which one is infinite hertz, but in the practical application which one is equal to the 1 to 2 megahertz. That particular op-amp having this performance or that means the amplification and the such any operations in the range of the 1 to 2 megahertz. The open loop gain, so that means the open loop gain of a ideal op-amp should be infinite, but in the practical application this one is 10 to the power 5. And seventh one is PSRR. PSRR is the power supply rejection ratio. It should be 0. So, the power supply rejection ratio for ideal op-amp should be the 0. So, that means the op-amp is a very high differential gain amplifier having a high input impedance, that means in the range of 2 to 3 mega ohm, and very low output impedance in the range of 75 to 100 ohm. So, this is the internal diagram, equivalent diagram of op-amp. In the op-amp, here two terminals, which one is inverting and non-inverting terminal. So, inverting terminal, that means if the output is to be the 180 degree phase out of the input voltage. So, we can say to such terminal is called the inverting input, and if the non-inverting input, if we apply a signal in a non-inverting input, the output is the same as the input terminal or input voltage. So, we can say this is a non-inverting input. So, this is a input impedance of a op-amp, we have to be just characterized, and this is the output voltage here, but here this is the, because this is a difference amplifier V2 minus V1 having a gain A, and this is the output impedance. So, this is the internal diagram of that particular op-amp having this is the plus V and the minus V is the supply for biasing that particular op-amp. So, what is the op-amp gain? So, we have to be calculate the what is the amplification of a first one application is non-invert or inverting amplifier. Non-inverting and inverting amplifier, we have to be utilize that particular op-amp. So this is the input resistance and this is the symbol of op-amp. This is minus denote the inverting terminal, plus denote the non-inverting terminal. This is the output and this is the pin number 6. This is the pin number 2, this is the pin number 3, this is the biasing voltage we have to be apply here, plus VCC and minus VEE. So this one is the pin number 7 and this is the pin number 4. So that is, this is a difference amplifier. So IC 74325 and 6 is the difference output. So we have to be utilized. So IC 741 we have to be utilized for that particular op-amp. This is the input impedance, input resistance, this is the feedback resistance of a particular operational amplifier. So what is the inverting gain of that particular amplifier, we have to be calculated. So this non-inverting terminal is to be connected to the ground of that particular supply, and here we have to be utilize that if V in the voltage we have to be apply at the non-inverting terminal. So that means due to the virtual ground condition, so that means the, if I can say this op-amp should be the ideal one, so that means the bias current should be 0. So I bias minus, which is equal to 0, I bias plus, which one is equal to 0. So that means this potential is equal to the this potential. So we can say this is a potential is same. That means the this voltage is 0 volt and this is also a 0 volt. And then we apply a KCL at point X. So that means if I can say this is V in, or if we can say this is I in, if we apply a KCL at node 2, so that means the I in, which one is equal to the IF, because if we apply a KCL, so this is the inlet current, this is the outlet current. So that means the I in, which one is equal to the feedback current, which is IF. So what is the I in? I in is the voltage potential difference upon resistance. So what is the potential difference in that particular branch? You have to see that we know that current always flow from higher potential to the lower potential. That means the V in potential is greater than 0 volts. So we can say what is the potential difference in that particular branch, which one is V in minus 0 upon, and this resistance is R in. So this is the current value of I in, that means the potential difference upon total resistance in that particular branch, which one is R in. What is the IF? IF is the current flowing in the feedback loop. So that means this is the feedback loop, this is output V out. So that means the what is the potential difference? So potential difference, because we have to be chosen that the current direction is from this node to the output voltage, that means that this 0 volt is to be greater than V output. So that means the what is the potential difference? Potential difference is 0 minus V naught. If we choose that the output voltage is V naught and the total resistance in that particular branch, which one is feedback resistance RF. So we easily calculate what is the V naught in terms of R in and RF, which one is V naught is equal to minus R in upon RF into V in. So we see that, so such operational amplifier having a gain in the inverting terminal, which one is minus Rn upon Rf. So that means the Rn upon Rf is the feedback factor, feedback gain of a inverting amplifier, and minus sign denotes that this is a inverting amplifier having a output is 180 degree out of phase of input voltages. So very important question we have to be designed for a non-inverting amplifier, so such that design a inverting amplifier, using IC 741, having gain is 5. So that means by using the IC741, that means that IC741 is a operational amplifier IC. So in that particular IC, we have to be design a inverting amplifier having a gain of 5. So we know that what is the meaning of the gain? Gain in the inverting amplifier, which one is feedback resistance upon input resistance. That means this is the gain. Inverting amplifier gain is represented by the feedback resistance upon the input resistance, which one is equal to 5. That means the feedback resistance, which one is equal to 5 into R in. Suppose we have to be calculate, and we assume that Rn is equal to 1 kilo ohm. So that means Rn is equal to 1 kilo ohm. So that means the feedback resistance value is 5 into 1 kilo ohm, which one is 5 kilo ohm. So that means if we use a feedback resistance is 5 kilo ohm and the input resistance is 1 kilo ohm, so they provide a gain of 5. So we design it very easily. So that means this is the op-amp, this is the inverting, this is non-inverting terminal, this is R in, this is the feedback resistance RF, and this is ground, and this is the input voltage, because we know that the Rn is, if we assume that Rn is 1 kilo ohm, so if we want the gain of that particular amplifier is 5, so that means the what is the RF value is 5 kilo. So we design easily what is the feedback resistance value and the input resistance value if we use a amplifier op-amp as working as a inverting amplifier. So second case is if we use a op-amp as a non-inverting amplifier. So what is the meaning of is op-amp works as a non-inverting amplifier. So suppose in the non-inverting amplifier, so this is minus, this is plus. So in a non-inverting, that means if we applied a signal on the non-inverting terminal, so we can say this is a non-inverting amplifier. So if we add this input voltage to the non-inverting terminal, so we can say this is a non-inverting amplifier. In previous case, if we connect a input in inverting terminal, so we can say this is a inverting amplifier. So by using the virtual ground condition, we have to be just explain what is the meaning of this. This is ground, this is R in, this is the feedback resistance RF, this is the V naught, this is IC741 having the biasing voltage plus VCC and minus VEE. So this is the circuit diagram of non-inverting operational amplifier. So suppose that by using this potential having voltage is Vi, suppose that op-amp should be ideal one, that means the bias current it should be 0 in inverting and non-inverting terminal. So that means this potential is equal to this potential by using the virtual ground condition. Virtual ground condition. So by using the virtual ground condition, this terminal voltage at 0.1, which is equal to the input voltage at 0.2, which one is Vi. So that means if we apply, suppose that the current flow in that particular loop is I1 and in that particular loop is I2. If we apply a KCL at node 2, so that means the KCL, apply KCL at node 2. So that means that if we apply a KCL at node 2, so that means the inlet current is equal to the outlet current, or we can say summation of I, which one is equal to the 0. So that means I1 is the inlet current in that particular loop and the outlet current, which one is I2, because this is the outlet current. I1 is equal to I2, that means in that particular loop you have to say that if this potential is higher potential, because the current direction is, we assume that from this to this, So that means I1 is the, what is the I1? I1 is the potential difference upon resistance. So I1 is 0 minus, because this is 0 volt, 0 minus Vi. This is the potential difference in that particular loop upon R in. This is the total resistance in that particular loop. This one is R in, which one is equal to the V in, because in that particular loop we assume that the current direction is there here. So that means V in greater than V naught in that particular loop. So that means V in minus V naught upon RF. So we easily calculate that V naught, which one is equal to 1 plus RF upon Ri into Vi. So in this case we see that the gain is plus, that means which denotes that if amplified output is the same phase at the input terminal. So that means the gain in non-inverting gain, which one is equal to the 1 plus Rf upon Ri. So this is the current gain. So this is the amplification voltage gain if we apply a Opamp as non-inverting amplifier. So suppose we have to create one example for non-inverting amplifier. So previous case we have to see that we design a non-inverting amplifier having gain is 5. So that means, suppose we see that in the previous question we design a inverting amplifier by using the IC741 having gain 5. So the feedback resistance is 5 kilo ohm and the input resistance is 1 kilo ohm. The same example we have to be utilized in if we use a non-inverting amplifier by using the Opamp. So that means how we calculate it? We know that what is the gain in non-inverting amplifier, which one is 1 plus Rf upon Ri. So that means 1 plus Rf upon Ri, which one is equal to 5. So Rf upon Ri, that means the feedback resistance upon input resistance ratio, which one is 4. So that means, which implies that the feedback resistance value is 4 times of input resistance. Suppose Ri we have to be taking 1 kilo ohm. So that means the feedback resistance is 4 kilo ohm. So by using this we have to be design a Opamp having non-inverting terminal, so having a gain of 5. This is Ri. So Ri we have to suppose that this one is 1 kilo ohm and this is connected to the ground. This is Vi and this is the feedback resistance Rf, which one is 4 kilo ohm, and this is output. So the output of this Opamp should be the 5 times Vi, because 1 plus Rf, what is the Rf upon Ri? Ri is 1 kilo ohm, which equal to Vi. So that means V naught is equal to 4 plus 1, 5 Vi. So we easily design a Opamp having a gain is 5 for both non-inverting amplifier case and inverting amplifier case. Third is Opamp works as an unity follower. Opamp works as an unity follower. So this is the application of non-inverting amplifier. So that means what is the meaning of unity follower? If unity, that means the unity means 1. Unity means 1, and follower, that means the which follow the input voltage. So that means if V naught is equal to the amplification gain is 1 into and follow the input voltage, that is called the unity follower. So that means V naught is equal to Vi. So in such case, this is the Op-Amp works as a unity follower. So in this case, you see that the phase difference between the output and input is 0 degrees. So that means this circuit is in non-inverting amplifier case. So we know that in the non-inverting amplifier case, the gain is Rf upon 1 plus Rf upon Ri, which is equal to 1. So that means Rf upon Ri is equal to 0. So in this case, Rf should be 0 ohm and Ri should be infinite ohm. So that means if we put this condition into the Op-Amp as in non-inverting amplifier, so this amplifier works as a unity follower. So this is the input which has to be followed. That means the so what is the meaning of if the feedback resistance is 0 ohm? That means this is short circuit. So any resistance is to be 0 ohm, that means the short circuit. So that means the feedback resistance is 0 ohm, that means this is short circuit, this is V naught, and the input resistance is infinite. So what is the meaning of this? Infinite is the open. So that means Ri should be infinity, or we can say this is open circuit. So by using the non-inverting amplifier, we utilize Op-Amp works as a unity follower.